De Moivre's theorem.
I believe
De Moivre's.
I believe this is French and it's pronounced De Moivre's theorem. But if you want to call it, if you want to show where you're from and say De Moivre's theorem,
we're going to talk about De Moivre's.
Yeah. So we first want to maybe remind ourselves about graphing complex numbers. When we talk about complex numbers, we instead of having the x and the y-axis, we have a real axis and an imaginary axis.
Fake.
Yeah, you might call it fake. It's imaginary, and
Is it like my imaginary friend? Hello,
No.
Mr. Bobo Skins. How are you today?
No,
I'm fine, thank you.
No, it's not like that at all. So what you do is you take the real part of the complex number, because remember, complex numbers are anything of the form a plus bi.
And every number is a complex number.
Is, because, for example, you could have the number 2, and that's really got an imaginary part to it. The imaginary part is just 0. So if we're talking about graphing complex numbers, you take the real...
hold on. I got an idea.
Oh, okay.
We could do this exactly like we graph x and y numbers.
Yeah, except for what is our x?
The first number.
Okay.
Just like x, y.
Okay, and what's our y?
The second number,
Assuming-
including the sign.
Assuming that it's in the right order.
Right.
And they're not
Well,
trying to trick us.
yes.
Because
You got me on that one.
The real part is the x, and the imaginary part is the negative 2.
Right.
So we go right 1 and then down 2.
There it is right there.
And that is the complex point, 1 minus 2i.
Right.
So that's just to get us like all on the same page. We're going to do all kinds of stuff with complex numbers, but we're going to have some familiarity to like vectors and polar equations that
We're still going to work some of that stuff too.
It's all going to look similar.
But the graphing part is, you've already done this kind of graphing. It's the same setup as long as you're in a plus bi form.
Yeah, definitely. So let's get on to something else.
Okay, let's do.
Okay.